In this problem, we're asked to calculate a gas's root mean square velocity at each of two temperatures. The problem itself is pretty straightforward. The only tricky part, I guess, is the application of a somewhat complicated formula. If you remember from your notes, root mean squared velocity is the square root of 3 times r times t all over the molar mass in kilograms per mole. Please note that the r in this case is 8.3345 joules per moles times degree Kelvin, not the universal gas constant stated in liters atmospheres over moles times degree Kelvin. And the other confusing thing is the molar mass is kilograms per mole, not grams per mole. So you would actually take a typical molar mass and divide it by 1,000. Maybe we'll start there. For chlorine molecules, to get its molar mass, it'd be 2 times the atomic weight of chlorine, which is 35.5, and you get 71 grams per mole. But if we convert that into kilograms per mole, it's 0.071. So let's use this formula at each of two temperatures. First, the temperature 261 degrees Kelvin. After crunching this number, it's kind of a big number, 92,030. But hit the square root button and you'll come up with something reasonable. 303. And since it's a velocity, the unit that comes out is meters per second. Now let's do the same thing for 539 degrees Kelvin. We'll apply the same formula. 3 times 8.345 times, this time 539 degrees Kelvin, all over 0.071, and we get square root of kind of a big number, 190,054, and we get 435 meters per second.